Today's lesson is on two-way tables, or sometimes referred to as Carnot maps. Two-way tables are an alternative to our Venn diagrams, display the same information, just presented in a different way. They can be written with numbers or with probabilities. Here you can see that there's two-way tables and the matching Venn diagram underneath. If you set up a two-way table, you put A and A naught in the two columns and B and B naught in the two rows. Where they intersect, the row and the column, this here is what tells us about where A intersecting B. The N in this case represents how many, represents number. In the second table you'll see that's been replaced with PR, so you're under the probability. So this means that belongs in both an A and B. If you look at the matching Venn diagram down here, that's this shaded region between A and B circles. For instance, if we go over here, this now says the number that's not in A but in B, and that is represented by this shaded circle here. We could have written as a probability. You have a total column and a total row. This value here would be the total number of people surveyed, or whatever the situation is. If a probability, the totals have to add up to 1. So going this way, it's got to add up to the total, or across this way. The probabilities going down that way add up to 1, or going across adds up to 1. And you can see the matching Venn diagrams. That's on your work booklet. Let's have a look at the example. A similar example to what we did with the Venn diagrams. In a class of 24 students, there are 10 students with at least one parent is born overseas, 7 students are fluent in the second language, and 4 who speak a second language and have at least one parent born overseas. So will that B equal the event parent was born overseas? Let L equal the event fluent in a second language. First we display this as a Venn diagram, then we'll do a two-way table, and then a probability two-way table. So it's the same Venn diagram as the previous class. We've got 24 students in total, 10 have parents born overseas, 7 who are fluent in the second language, and 4 who are both. So that's why that becomes 6 and 3, and there's 11 people obviously who are neither. So in a two-way table we'll have our categories B and B naught and L naught. So in this case I've decided to put L in the columns and B in the rows. You can have it that way around, it doesn't make any difference. If I put in the information that we already have from the question, 4 people are parents born overseas and speak the second language fluently. So where they intersect, that's where I put that 4. There's 7 who can speak a language, so the total is 7. 10 have parents born overseas, so the total is 10, and there's 24 in total to start with. So from here we can work out what the missing number here is. This would have to be 6, this would have to be 3. And going down this way, this would be 14, this here would be 17, therefore that makes that vacant spot there 11. Alright, that's if we say it's a number two-way table, because I've used the raw numbers. If we want to change this to a probability, we need a little bit more space, so I'll have to go to the next slide to fill this in. We use the same numbers we just had on the previous one, like 4, 6, 3 and 11, but now we divide it by the total number of people, which was 24. Sometimes the fractions can be simplified, as those 3 are. Sometimes they can't be simplified, like this one here. And we expect it to simplify our fractions. So now we can answer some questions asked here. What's the probability of B? Well, B is made up of 2 parts. So add them together and we get the answer 5/12. Probability of L, so we look at the L column, go down to the total, and it's 7/24. What's the probability of B intersecting L? That means it belongs to both B and L, so that's this section here. And so it's 1/6. And the last one says B union L. Everything that's in B and everything's in L. These slightly shaded 3 here are everything in L, everything in B. So we'd add those 3 things together. 4 plus 6 plus 3 is 13 out of 24, or take 11 away from 24, because that's the bit that's not in B or L. 2 different approaches. There's and this one here, you add everything's in B, everything in L, and take away this bit here, because this, if you count everything in B, which is that, and everything in L, unless you've actually counted this section twice, so that's what that second calculation shows. So the answer is 13 out of 24, whichever way you do it. Right, here's another example, two-way table, where some college students are asked to choose which of the three subjects they enjoy the most, English, Maths or Science, and split into category of boys and girls. You can see there's a few things we can add up here. The 20 English for girls, so there's 38 in total, so it must be 18 there. 13 and 15 like Maths, so in total that'd be 28. I can add across this way to get the total now. I can work out this missing number here by 20 and 30 makes 33, and what makes 50, 17, etc. So that's where that comes in. If that total's 40, then that must be 23. Just to explain that before, 20 and 18 make 38. Adding across this way, I get 56. Adding vertically, I get 38. And adding horizontally there, comes to 106, or vertically comes to 106. That's how you check that your two-way table's correct, and it's the same in both directions. Now you can answer some questions. What's the probability of these things? Those who chose science as the favourite subject, so it doesn't just specify girl or boy, so that's the total number of like science, so that's 40 out of 106, which can be simplified to 20 out of 53. Chose English as their favourite subject, so 38 out of 106, which simplifies to 19 on 53. Was a boy, so how many boys were there? It's 56 out of 106, simplifies to 28 out of 53. Girl whose favourite subject was English, so that could be girl and English, so there's 20 girls like English out of 106, which simplifies to 10 on 53. Was a boy whose favourite subject was Maths. Boy, Maths, 15 out of 106. Right, they're the questions we've done from this section. Thank you.